Now members, let us see how we handle this proof here. So, show that the possible values of this, if alpha is the first approximation to the root this, show that the second approximation is going to be this. Then there's an next part here, show that the roots of this are between this, and hence use the formula above to determine the root correct to 3 decimal places. So all we know is the function, so meaning if I'm to handle this, I say let my f of x be x power 5 minus b. Meaning I need it evaluated at xn to be x5 power n minus a b. In simple terms, that's it. Then when it's derivative, f prime of x. Here we have initially to get 5 x power 4. This one goes to 0. Now substituting into this formula, so xn plus 1, I'll be having xn minus the function. Our function is here, and evaluated at n xn, the whole over the derivative 5 power 4 n. Now here what we do, we cross multiply. We get the LCM, this and this, so we shall have 5x n. This time this will get power 5, then minus, so we open brackets, get x5 n, then plus b, the whole over 5x power 4 n. Now you see, if I factorize out 1 over 5, I remain with, we simplify this, we get 4 x squared n plus b, the whole over x power 4 n. When I divide this here, when you look at our proof here, so I need to divide it in this. Okay, when you look at our proof, we have x power 4 here, and then what is a? Sorry, this is 5, not 2. This is 5. So in this, divide this, so it's that our xn plus 1 will be now 1 over 5 into, when you divide this here, you get 4xn, then plus b over x power 4 n. And you see, now our initial taking this alpha as our first approximation, so taking our x not to be alpha. Now this will be now x1, the next root will be 1 over 5 into now 4 alpha plus b over, where it is, I'm putting alpha power 4. And see that that is our next approximation of our second approximation. Is going to be 1 over 5 into of alpha power 4. Now after that, show that, then in part B, so this one is done. That is the proof. So they are telling us that hence so that the possible roots for this equation, so you know that our f of x is going to be now x power 5 minus 17. So that is between 1.5. So f of 1.5 is going to be 1.5 power 5 minus 17 equaling to, just get that and then replace it on the calculator. 1.5 power 5 minus 17. So this one is going to give us 9.4. Then f of 81.8 is going to be 1.8 power 5 minus 17, which is going to be 6, giving us 1.89, and it's that f prime. Then f1.8 is giving us a negative, so it's less than 0, hence a root Now using the formula above, the direction start using the formula above. So now we take initial. So you can use in this root the initial. So meaning if I use this formula above, now I'm going to use here from my xn, start my b is going to be 17. If we compare this and this, how was x power 5 minus b equal to 0, then x power 5 minus 17 equal to 0. So that our b is 17. Putting it here, now I have xn plus 1 equaling to 1 over 5 now into, now my first approximation, I didn't mean that. Now I'm going to take my first approximation for xn plus b over x power 4 n. So I'm going to take my alpha b. Let me use this first, the first root, because it's between this and this. Let me take this to be my initial approximation. 1.5. Let me take it to be 1.5. 1.5, which is going to be our initial approximation. Okay, so taking our initial approximation, now the second is going to be, we just substitute here. Our x1 is going to be into 1.5 plus our b. Now our b is 17 over 1.5, the whole power 4. I told you how to paste this on the calculator. But now our tolerance is going to be, because the 1 is to 3 decimal places, it's going to be 0.5 times 10 power, and that is 3, which will be 0.005. So, when we press that on the calculator properly, you see I'm going to be adding 4. So if I put in my first 1.5, I'm getting 3.3667 for decimal places. Yeah, that's the value I'm getting. Now, it means that now, after doing that, now we come to the next root. So my x2 now is going to be, sorry, no, that's not the root. Sorry. I made some. Sorry. 4 alpha power 4 was the bracket and cross. Okay, so when I put in that value, I get 9. Sorry, let me show you how we do that value on the calculator. I think you can see how I am pressing it on my calculator. That's how I'm pressing it, the whole value, the whole thing on a calculator there. That's how I'm pressing it. Then I pressed equals, that's the value I got. So the value I got is 1 point, so this is not the value, sorry. The value I got here is 1.8716. Now when I press in, you press color again, then you press in. Now this is going to be our next root. 1.871.6. Press equals. Here, I'm getting 1.7744. So you see that now, when I get this difference, it's still not less than this. So I go for x3. My x3 is going to be 1 over 5 into 1.774. 4 cross plus 17 or 1.7744. The whole power 4. We press that. Our x3 is going to be, you press down, then you press that value 7.744. The value I'm getting is 1.7625. And then you check, have you reached your tolerance yet? You get this minus this, and you see that the tolerance is not going to be. If I'm showing you there, the value I'm getting is that. Let me first check the sunshine now, by the sunshine disturbing, but that's the value I'm getting. Now, you see that it's not yet, the error is not 0 less than the tolerance. So we go for one more round. So checking for my x power 4, it's going to be 1 over 5 into 4 into now this 1.7625 plus 17 over 1.7 then cross this, and so your x power 4, x4 is going to give you 1.76 to 5. What I'm getting is 1.76 to 3. Then you see when I check on the tolerance x4 minus x3, the error I can tolerate is that when I subtract this from this, I get 0.0002, which is less than that total. So this is okay. So therefore, my root will be 1.762. We say 3 decimal places. 3 decimal places. But now I want to pose a question here. If I'm posing a question, why do you think here we used a lot of iterations? It's because our initial value was far. The value, if maybe we had chosen 1.6, then we'd have reached earlier. But because it was 1.5 there, that's why it was far from this. Anyway, but good enough, we have reached the Canaan land. So that's it, members. I think we have exhausted most of the questions in Newton's Raphson method. Next week, we are going to handle the flow chart next to this, but you need to have this idea to come to flow chart because we are going to apply them there. That's it, members. Wish you well.